Okay, so the first part of this video we're going to spend looking at the value e. Just like pi, we know pi is rounded at 3.14. E is another number that is rounded at 2.71, and it's called Euler's number. So if you ever see this name, that's Euler. This is his number. Okay. So just some things to note. If you have y equals e to the x, what you are looking at is y is equal to 2.71 to the x. We've seen y equals 2 to the x. We've seen y equals 3 to the x. And so what I'm going to do is I'm going to show you on Desmos what e to the x looks like as a graph. It's no different. So this is the worksheet that we'd technically be working on if we were in class, but since we're not, we're just going to use Desmos right now. So what I want you to see, we're going to put y is equal to, e to the x. Okay, and then I'm also going to show you y equals 2 to the x, and y is equal to 3 to the x. So you can kind of see that e to the x falls right between 2 to the x and 3 to the x because it's 2.71. And so my main point here about all of this is that it's just another exponential function, and so it's not much different than the other ones, 2 to the x and 3 to the x, that we've done previously. So if we were to put x values here, we'd put 0, -1, -2, -1, 0. Let's do those real quick just so I can show you what it'll look like. So I pull this up. If we do 0, oh, my pen's not working. What's going on here? It says shift. I don't know why. Let me see. There we go. Okay, so here we go. If we have, for instance, let's do it over here, -2, -1, 0, 1, and 2, then e to the -2 is going to equal 1 over e squared, which is equal to 1 over 2.71 squared, which if you use a calculator, same thing, it's going to be just like 3, 1 over 9, this is going to be close to 1 over 9. If we do e to the -1, we have 1 over e, which is simply 1 over 2.71. If we do e to the 0, we have 1, because anything to the 0 is 1. E to the 1 is simply going to be e, which is equal to 2.71, and e squared is equal to e squared, and so that's going to equal 2.71 squared. Okay. So if we do each of those, you can see it's basically the same thing as before. Domain and range, same thing. We've got domain being -infinity to infinity. Range is 0 to infinity. Notice we are not including 0 because it will never equal 0. And so when we look at the e to the x, this would be filled in. Domain and range, you've got that. ln of x is the same thing as e to the x, only it's the inverse function. So when you take the log of something, base e, we call this ln, natural log. And so it's just a special notation we use when we're talking about a log base e, which is 2.71. There's nothing incredibly, well, I mean, we use the natural log for a lot of formulas because e actually has a lot of real-world applications, which we'll eventually talk about. But the point of this video is just to do the domain and range of these two and then look at some transformations real quick. So we've got, sorry, not this one. We've got the domain and range. Obviously, you'll just switch these two. So the range here, the domain here is going to be from 0 to infinity, not included on both ends. And then this one's going to be from -infinity to infinity. Now, if we look at the transformation for a exponential, we have y is equal to ab to the x minus h plus k. where h and k, obviously h is lying again, k is telling the truth, as we said in class, just to help you remember that in the formula it's going to be the opposite for h, and k will just be what k is. So if we look at a problem, we got this one. We're looking right. Oops. Y equals 3 to the x plus 1. I think that's what it is. 3x plus 1 minus 2. Okay. If we look at this one, all that's going to happen is this is going to tell us h is -1, k is -2. And so remember at 0 originally, if we were to graph this, we'd have x, y. If we had 0, if we plug 0 in, we would have a point at 1. Okay, so if we have the graph y equals 3 to the x, it goes through that. I know I missed it a little bit. Let's make that a little bigger. But if we were to graph this as y is equal to 3 to the x, this is the parent graph of this because 3 is b, then we would go through that point. Now this h and k is going to shift this point -1 units to the left, 1 that way, and 2 down. So we're going to go 1 that way and 2 down. So we're right here now. Okay. And it's also going to, remember, there's an asymptote secretly here, and I'll draw it in red. Okay, it's at 0. It's also going to shift that asymptote down 2 from where it is originally, so I'll do that in blue. Okay, now the asymptote's here, and if we draw the graph, it's going to go something like this. We don't have to be perfect. I'm more concerned that you understand how the transformation is working. And so in this case, the domain here doesn't change, -infinity to infinity. But the range, however, does. And the reason the range changes is because now instead of the lowest points being found at 0 or around 0, they're found 2 units further south of 0, and that would be at -2. And so the range is now -2 to infinity. Okay. And so I just wanted to point that out to you. We'll do another example real quick. Let's look at -log base 2. Actually, I'm going to end this video. I don't want it to be too long for you. I'll do a second video to show you the next ones. Thanks, guys.